This Introduction to Python series is part of the EPSCoR Track 2 DDMD workshop. This lecture is on Python iterations. There are times within our Python program where we want to repeat a group of statements numerous times. This is referred to as a loop, and each pass through the loop is referred to as an iteration. So there's two types of loops. One is a definite loop, where we have a predefined number of times when we want to repeat a group of statements. The other type of loop is an indefinite iteration, where we're going to repeat a group of statements based on some condition. So for example, let's say within our Python program that we want to print the integer 0 for 5. So we could write 6 print statements and print each one of those integers. But what if for some reason we wanted to print all of the integers 0 through 1,000? It would be pretty inconvenient to have to write 1,001 print statements. In Python, a for loop is used to iterate over a range. A for loop allows us to specify the number of times we want to repeat the execution of a group of Python statements. So this is how we would leverage a for loop to print integers 0 through 5 rather than writing 6 print statements. So in this example, X is our variable, and it's assigned the values within the range 0 through 5, and each iteration through the for loop, the value of X is printed on the screen. So now if we want to modify our code that'll print the integers 0 through 1,000 instead of 0 through 5, all we have to do is change the argument within the range function from 6 to 1,000. Here you see the general format for a for loop. The first line of code is referred to as the loop header and begins with the reserved word for. It's followed by a variable, then in, then the range function. Every statement that you want repeated within the for loop must be indented under the loop header. To loop through a set of code a specified number of times, we use the range function. The range function returns a sequence of numbers starting from 0 by default and incrementing by 1 by default, and ends at the specified number. So for example, we have the for loop for X in range 6. Notice that the loop header ends with a colon, and every statement we want repeated under the for loop or within the for loop is indented. So the statement that's going to be under the control of this for loop is the statement print X. A general concept in Python is the indentation. Indentation determines the grouping of statements. Python programs get structured through indentations. In other words, code blocks are defined by how they're indented. All statements with the same distance or the same indentation to the right belong to the same code block. The block ends at a line with less indented or the end of the file. Generally, white spaces are used for indentation and is preferred over tabs. The range function within the for loop returns a sequence of numbers starting from 0 by default and incrementing by 1 by default, and ends at the specified number. So range 4 will provide X with the values 0, 1, 2, and 3. Let's consider how the computer executes a for loop. So given this example, we have a for loop that's going to print the values 0 through 3. First, the computer assigns the variable x the value 0. The computer checks to verify that the value stored in x, and in this case 0, is within the range 0 to 3. Because 0 is within that range, the print statement that's indented under the for loop is executed, and therefore 0 is displayed on the screen. Next, x is assigned the value 1. The computer verifies that the value stored in x is within the range 0 to 3. 1 is within that range, so the print statement is executed and 1 is displayed on the screen. The computer increments the value stored in x by 1. Therefore, 2 is assigned to the memory location x. The computer verifies that the value stored in x is within the range 0 to 3. X is equal to 2. It is within that range, so the print statement is executed and 2 is displayed on the screen. X is again incremented by 1, so now the value stored in x is 3. The computer verifies that the value stored in x is within the range 0 to 3. 3 is within that range, so the print statement is executed and 3 is displayed on the screen. X is incremented by 1 and the value stored in x becomes 4. The computer verifies that x is within the range, and because range 4 will include the integers 0, 1, 2, and 3, 4 exceeds that range, and therefore the execution of the for loop is complete, and the next statement that's executed is the next Python statement that follows the for loop. In other words, the statement that is not indented within the for loop. Therefore, the computer executes the print statement containing the string loop is complete. So loop is complete is displayed on the screen. The range function takes 3 parameters: start, stop, and step. Of these 3 parameters, 2 are optional and may be omitted: the start and the step. A start parameter is a starting number of the sequence, or the lower limit. By default, it starts at 0. A stop parameter is the upper limit. In other words, generates numbers up to but not including that number. The step is the difference between each number in the result. The default value of the step is 1 if not specified. As mentioned before, in the range function, the start value defaults at 0. However, it's possible to specify a starting value by adding the parameter. So given the example range 2, 6, the start value is 2 and the stop value is 6. So in this example, I is first assigned the value 2, and we print that 2 on the screen. It's incremented by 1. We print 3. It's incremented again by 1. I is equal to 4. We print 4. It's incremented again by 1. I is equal to 5. We print 5. And I is incremented again. I is equal to 6. That's the stop value. So that's the end of the for loop. And the next statement that's executed is the print with no parameters, which is not indented within the for loop. The range function increments the variable by 1 as a default. However, it's possible to specify the step value by adding a third parameter. So in this example, we have the function range. The start value is 1, the stop value is 10, and the step is 2, which means the value starts at 1, stops at 10, but not including 10, and the variable is incremented by 2 on each iteration. So given this example, I is assigned 1 as the start value. Then we print I. I is incremented by 2. We print 3. I is incremented by 2 again, therefore I is equal to 5, and we print 5. I is incremented again by 2. I is equal to 7. We print 7. I is incremented again by 2. I is equal to 9. We print 9. I is incremented again by 2. I is equal to 11. Therefore, I is equal to or exceeds the stop value. That terminates this for loop, and the statement directly following the last indented statement, which is a print statement, is executed. Let's say we wanted to write a Python program that would calculate the sum of the integers between 10 and 20 inclusively. To do this, the first thing we would need to do is initialize the variable sum to 0. So we would assign 0 to sum. Then for each integer, 10 through 20, we would add that integer to sum. And then finally, we would print the sum to the screen for output to the user. So for that example, this is what the code would look like. So we would initialize sum to 0, and then for each integer 10 through 20, we would assign that integer to I, and then add I to sum, and then when the for loop has completed, we would print to the user the sum of the integers between 10 and 20 inclusively is 165. Let's look more closely at how the computer executes this code. To begin with, we say sum is assigned 0. So we have a variable memory location called sum, and we assign it the value 0. Then at the beginning of the for loop, I is a variable memory location, and it's assigned the start value 10. So at the beginning of the first iteration, sum has the value 0, and I has the value 10. So basically, in the first iteration, we're taking sum, which is 0, and I, which is 10. We're adding 10 plus 0, which is equal to 10. So we're taking 0 plus 10, which is 10, and we're assigning that to the memory location sum. So now sum contains the value 10. Now in the second iteration, I is assigned the value 11. So when the computer executes the statement under the for loop, sum is assigned sum plus I, sum is 10, and I is 11. So the computer is adding 10 plus 11, or 21. And 21 now is assigned to the memory location sum. So after the second iteration, I is equal to 11 and sum is equal to 21. This table shows how the variable I and sum changes through each iteration. So for example, the first iteration, I contains the value 10, and before sum is assigned sum plus I is executed, sum is equal to 0. After sum equals sum plus I, sum has assigned value 10. Now the second iteration, I is assigned the value 11. Sum is equal to 10. Sum is assigned sum plus I is executed. The computer adds 11 plus 10, assigns it to the variable sum, and so sum contains the value 21. Here's another example of a for loop that's provided to us by Python, where we can take a string and print each character in that string. So for example, we could assign first name the value Carol. So our string is Carol and it's assigned to the memory location first name. Then we can write a for loop where we assign letter to each letter within first name. So the way the computer executes this code, letter is assigned the character C, and that character is printed on the screen. Comes back up, letter is assigned the character A, prints A, and so forth until the computer reaches the end of the characters in the string. Let's look at an example where we want to calculate the average grade. So in other words, given a set of grades, we want to add that set of grades, divide it by the number of grades to calculate the average. So for our algorithm for this problem, first thing we're going to do is ask the user, how many grades would you like to average? Then we're going to initialize the sum of the grades to 0. And then for each grade, we're going to ask the user for a grade, and we're going to add that grade to the sum. Once we've received all the grades from the user and calculated the sum, we're going to calculate the average by dividing the sum by the number of grades, and then we're going to print the average for the user. The first thing we want to do is ask the user the number of grades to be averaged, and we want to initialize the grade sum to 0. So the first line of code is use an input statement to get the number of grades from the user, convert it to an integer, and assign it to the memory location grade number. The second statement in our program is to assign the grade sum the value 0. So in our example, the user has specified that there are 4 grades to be entered. So at the beginning of our for loop, we have that the grade number is 4 and the grade sum is 0. So our for loop, I is going to be assigned the integer values 0 through 3, which will cause the 2 statements under our for loop to be executed 4 times. So 4 times, we're going to ask the user to input a grade. We're going to convert it to an integer, and then grade's going to be assigned the value entered by the user. Next, we're going to add that grade to our grade sum. After the user has entered all the grades and we've added the grades to grade sum, we're able to calculate the average. So the average is assigned the grade sum divided by the number of grades. And lastly, we can output that information to the user. So here's a completed example of our program to calculate the average of a group of grades, where we ask the user to enter ahead of time the number of grades to be averaged. So for each grade, we get the grade from the user and we add it to the grade sum. and then we're able to calculate the average and output it to the user. Recall that in our example of calculating the average of a group of grades, we asked the user ahead of time the number of grades to be averaged. That's a definite loop, and we know the number of iterations ahead of time. But there's times that the number of required iterations is not known ahead of time. Therefore, we want to create an indefinite or a conditional loop that's based on some condition. An example of an indefinite loop is a while loop. And the general format of a while loop is while some condition, then you have a body where the condition is a Boolean expression. So it evaluates to either true or false. And the body is a sequence of one or more Python statements. So semantically, the body of the loop executes repeatedly as long as the condition remains true. As soon as the condition becomes false, the loop terminates. The condition is tested at the top of the loop. This is known as the pretest. So if the condition evaluates to false initially, the body of the loop is never executed. So here is an example of a while loop that prints the integers between 0 and 10 inclusively. So we initialize the variable I to 0. And as long as I is less than or equal to 10, so that's our Boolean expression, I less than or equal to 10. That's going to either be true or false. As long as it's true, we're going to print I, and then we're going to increment I. So now I is going to be equal to 1. As long as that's less than 10, we're going to print I. That code has the same output as the for loop for I in range 11, print I. Importantly, the while loop requires us to manage the loop variable I by initializing it to 0 before the loop and incrementing it at the bottom of the body. In the for loop, this is handled automatically. The while statement is simple, but yet powerful and dangerous. They are a common source of programming errors. So if you look at this while loop, I is assigned 0, and while I is less than or equal to 10, print I. What would happen to this code? When Python executes this loop, I is equal to 0, which is less than or equal to 10. So the body of the loop is executed, which is the print I statement. Now control returns to the condition, and since I is still 0, the loop repeats. And there is nothing that's going to cause the loop to terminate. This is an example of an infinite loop. So as demonstrated, every now and then you will run code that runs forever. So you've accidentally created an infinite loop. Within the Jupyter Notebook, to stop code from running, press the stop button. Let's look at an example where each iteration of the loop, we ask the user if there is more data to process. We need to preset the more data to yes to go through the loop the first time. So we would set more data to yes, then while more data is equal to yes, get the data from the user, process the data, and ask the user if there's more data. And this loop will continue until the user does not answer yes to the input question, is there more data? We're going to modify our calculate an average grade example by, instead of asking the user up front, how many grades would you like to process? we're just going to continue to ask the user if there's more grades to enter, and we're going to continue getting grades, adding them to the sum until the user has no more data to enter. So we're going to set more data to yes. We're going to initialize our grade sum to 0. We're going to initialize the number of grades to 0. And while more data is equal to yes, we're going to get a grade from the user. We're going to add that grade to sum. We're going to increment the number of grades. Then we're going to ask the user if there's more grades to enter. We'll continue that while loop until the user does not answer the question yes to is there more data. After this loop, we'll calculate the average grade and print the average grade. Here's an example of how we would solve that problem. So to solve it, we initialize the variable more grades to the value yes. We initialize grade sum to 0, and we initialize number of grades to 0. Now, while more grades is equal to yes, and initially that's true, we ask the user to enter a grade, convert it to an integer, add that grade to sum, increment the number of grades by taking the number of grades and adding 1, then asking the user, are there more grades to enter? We go back up to the top of the while loop. If the user had responded with the string yes, more grades is equal to yes, and the bottom of the loop is executed again. And that body of the loop continues to be executed until the user does not respond with yes. Then the next line under the bottom of the while loop that is not indented is executed. So we calculate average. We take this grade sum, divide it by the number of grades, and that gives us the average. Now we tell the user there were 4 grades entered, and the average grade is 78.75. Yet another way you can solve a problem is by using a sentinel. So a sentinel loop continues to process data until reaching a special value that signals the end. The special value is called a sentinel. The sentinel must be distinguishable from the data since it is not processed as part of the data. So when using a sentinel loop, you get the first piece of data or the first data item. And while that item is not equal to the sentinel, you process the item and you get the next data item. And you will continue this until the data item entered is equal to the sentinel. So the first item is retrieved before the loop starts. This is sometimes called a priming read since it gets the process started. If the first item is equal to the sentinel, the loop terminates and no data is processed. Otherwise, the item is processed and the next one is read. We can modify our calculate average grades using a sentinel loop. And we can do this because we can assume that grades cannot be negative. So we can initialize the sum to 0, we can initialize the number of grades to 0, and then we can ask the user for a grade. And while this grade is greater than 0, we can add the grade to the sum, increment the number of grades, and get another grade. We'll continue in this while loop until the grade that's entered by the user is a negative number. Once we finish the while loop, then we can output the average. Here's an example of what the Python solution might look like for that calculate average problem using a sentinel. So first we ask the user to enter a grade. Then we initialize grade sum to 0 and we initialize number of grades to 0. While grade is greater than 0 is true, add the grade to grade sum, increment number of grades, and ask the user to enter another grade. Convert it to an integer and assign it to the grade variable. Go back up and check the condition again while this grade is greater than 0. So note the time in the iteration where the user enters, let's go to the iteration where the user enters a 90. So the user enters a grade of 90. 90 is greater than 0. We add 90 to grade sum. We add 1 to the number of grades. Then we ask the user to enter another grade and the user enters a -1. We go back to the top of the while loop and we check the condition. -1 is greater than 0 is false. So specifically take note that -1 is never added to the grade sum and we never increment number of grades. So the sentinel is never treated as part of the data set.